What is going on, guys? Welcome back to the next video in learning discrete mathematics. My name is QTS Dani and you guys watching my channel Croywood. Alright, so we begin with describing sets. We're gonna see what is set. A set is simply an unordered collection of objects, and it is the foundation for most of the mathematics. These objects can be anything imaginative. It can be letters, it can be numbers, it can be images, it can be colors, it can be cats, dogs, whatever you guys can imagine. It can be zoo animals, it can be dinosaurs, so anything you guys can imagine. And if you haven't heard of these objects in computer science, we see objects as something. In plain English, we call objects as something that around us, like an apple, like a tree, like a human, animals, whatever. And in computer science, we say objects is something that has attributes and has something that has properties. What we mean by properties is the legs, it has a hands, it has some sort of function. So this can be as a properties, as has attributes, has a we mean the person, the way person talks and the person walks, something like that. That's attributes. Okay, so a set, and I'm gonna describe the set again, is simply an ordered collection of objects. We can also say that the set is a collection of items. So most of the time you guys is going to see here that the description of the set comes in a collection of items, but for the broader ones, we're going to see that the set is a collection of objects, and we're going to prove to you guys how. We refer to the objects in a set as the member or elements of the set. So whatever inside, you guys going to see this is a container, and you guys see here there is dots here, the circles here. We see this is a member or elements of the set. Sometimes you can see this one as a member, and sometimes you can see this is an element. And we're going to give some example. The first one is we have a house and it has a school. Keep in mind, if you're looking on the left and right, we begin the set with curly braces open, and we end our set with the curly braces closed. And this set, which is contain the house and school, it has two elements, house and school. And the second one is here we have horse, chicken, lion, zebra. It has 4 elements. And the third one is we're gonna see that's 1, 2, 5, 10, and 20 and 50. If we count, it's gonna be 1, 2, 3, 4, 5, and 6. These ones have 6 elements, and that's how we can visualize the set. Humans, we as humans, we are very good at visualizing stuff. We are not humans are not very good at say, for example, if I put it set in this way, this is called rigid. We are not very good at visualizing these things, but if I can put it this way, say if I put a for example, if I come here and I'm gonna bring a pen, and if I can put an X, and if I put equal, and if I put a curly braces open, so now most of us can better visualize this way. So that's how we're gonna visualize. Say if I put this one is gonna be, say for example, lion, for example. So if I say this is the number of lion in a zoo, so we can see that 6 and 9, this is the set of zebras, our set of say for example dinosaurs, our set of apples, our set of trees. So we can most of us, we can visualize this way. So that's how we're gonna visualize this way. There is a, say if we put this one from the beginning to the end, there is you put it like a container, and inside this container is we have our objects. So we're going to describe a set as we look at the set by its elements. The set order is not important. So we look at the whatever set we have, we look at the elements. Say for example, this set here, A, B, C, and D, can be also written as B, A, C, D. So we don't look at the order, we look at the set by all the elements inside here. And we also have here 5, 10, 30, 50, and 70. and we can also put it the other way around. We can put a 30 and we can put a 10 5, we put a 70 and 50. So this set here above and this one here on the right is both the same, and this set here on the left and this set here on the right is both the same. We don't look at the order, whatever order it is, we look at the elements or members. The most important thing is that we can also write the above is we can put a double A, because we have a here, and we can put a totally different order. So this is in order, but this is sorted, and in order this is an order. So as the previous slide we said, the set is an order collection of objects. We can put it also as A, B, B, C, C, and D, D. And this one here is we can also put a 5, double 10, double 30, 50, 50, 70, 70. We can also put it this way. So they're all the same. We can see this one and this one and this one the same, and we can see this one and this one, and this one is the same. We need some notation to make talking about sets easier. As I said in the previous video, like we can put an X, and that's our container, and inside the container that's our objects. We have 10, 20, 30, 40, and 50. And we're going to read this one as X is the set containing the elements 10, 20, 30, 40, and 50. That's how we're going to put a notation. You can put a A, you can put a B, you can put a C, you can put a D, you can put a dinosaur, you can put anything here. You don't have to put an X. But most of mathematicians, they prefer to put a B, C, or X, Y, Z. So we use curly braces, and we look here, there is a curly braces, and the most important ones is that we use the curly braces in a set, and there is commas here to enclose the set of elements. Think of these curly braces from here which we begin with to here which we end inside is just like a container. And we continue our discussions working with sets, and we're going to see the notation. We use E, just like looks like we can see this one as epsilon to describe membership of the set. We read E, if you guys look in here, that's E is epsilon. So we can read this one, A is element of B. When you see here AEB, don't read it as AB, AEB. It means that A is the element or member of B. So that's how we're going to write here. We're going to write this one is a B, and then we're going to put a say inside this one container. We can put a B, C. And now we're going to see here that X is not the element of B because we don't see X here. So if I put a say for example B equal to, and I put it here, say this is a container, and inside the container it has objects, our you guys can see members, or you guys can see our element. So this B now has element, and that's how we guys, whatever you guys represent here, you can represent this one. You don't have to we can visualize it this way, but to make it short we can do this way. So this is a very short version of this one. So we put a B equal to, there is a B, C inside the curly braces, and we can see the objects here. There's also objects that you guys can imagine this one as a dinosaur, pets, dogs, cats, whatever you guys can imagine. That's how you guys we can visualize, and that's how we can just go somewhere and says that's our say for example set, and we can just draw a container here, and we can put a curly braces. The reason I'm doing here is because I'm just showing you guys, because we are very good at visualizing stuff, and that's how our container is inside here. That's how we visualize this one. But when we come here on the paper and properly, that's a formal definition. That's how we're going to write this one, that the A is an element of B and X is not element of B, because if you don't, we can see X here inside here. So if we have a say for example Y, we can say that the Y is not element of say B. So when you see the epsilon and you see there is a line here, it means that's not an element. So I'm going to remove So the symbol E, you can see that's a funny E, is read is in. So when you guys going to see this one is in, because A is in B. We can see B is in B. We can see C is in the B. So that's how you can see. But we can see that X is not in, is not in, our is not an element of. So X is, A is element of B, our X is not element of B. Thus the above mean that A is an element of B and B is the set containing the letters A, B and C. Note that this is a true statement. It would also be true to say that D is not in that set. So the last one, if you observe here that this is a true statement, and the above we can see here, this guy here is true. This also in a sense is a true, because we can't see X here inside the B, set of B, but as I said to you guys, here is also be true that to say that D is not in that set. So if someone asks you if is the D inside the, say for example B, our we can do this one and we can draw epsilon here and we can put a B. Is it true? No, it's not true. But when you put a not, it means that becomes a true, because D is not inside the B. D is not inside the, is not an element of B. Now how we can describe say very large our infinite sets. For example, if we have a huge set, as we say is element, or we have infinite number of objects, how we going to decide put it here. So we're going to put ellipses in between. Alright, so now that we know about the set and we have seen the elements or objects of the set, so now we are in a position to we can describe our set. So we dive in a little bit, we're going to get a little bit advanced, and we're going to describe a very complex sets. The words set and elements are undefined terms of the set theory. As the name suggests here, set and elements are undefined terms of the set theory. Just as the sentence true and false, because when we see the sentence, sometimes we don't know if it's true or false till we is going to send the ends or undefined terms of logic. Be warned, we write X is element of A when we wish to express that one of the elements of the set A is X. For example, consider the set, and we're going to look at the set. We have a set of A which contains our elements, has a members, our elements have a 5 C, it has another set XYZ, and there is an empty set at the end. This is a strange set to be sure, and if you look in here, we haven't seen this one before. As before we have seen the zoo animals, we have seen the lion, tigers and pets, we have seen a house, we have seen a letter, we have seen an alphabet, alphanumeric, and we haven't seen that, like say for example this one is 5, number 5 is numeric, this one is a character, there is another set here, and there is an empty set sitting at the end, and this is a very strange set, and we all agree it contains 4 elements. So if you look in here, 1, 2, 3 and 4, there is a 4 elements. We count this set as a 4 elements. If you don't know this one, when you see there is a set sitting inside another set, we count this one as objects, or we can see this one as element. You can see this one as items as well, and we can see the number 5, the letter C, the set XYZ, and empty set. So we're going to see that is I is in A, and we can see I. If you guys, can you guys find I for me, because you guys can't find, because we have a 5, we have a lowercase c, we have another set X, Y and Z, and there is a empty set here, but we can't find I because I is not inside A. So now if we consider that we have another set which has a 5 and C, and if you look in here, the set of A has a 5 and C. So what about set of B which has also 5 and C? So the set of A which has a 5 and C, and the set of B which is also have a 5 and C, they have a common items here. Even though the elements of B is the elements of A, as I said to you now just before, but we cannot say that set B is one of elements of A. Therefore B is not an element of A. We cannot say that one because set of B and set of A is two distinct. But we cannot say that set B is one of elements of A, because here we cannot find here another set which have a B here. Say for example, if for example we had another one here which says B uppercase, then we could say yes, this is true, and we could say that B is like that. It's like that, but because this B was inside this container, because now B is not element of A, that's what we can say that one. Even though sometimes we come here in the different scenarios, and you're going to see that the different sets have common elements. Say for example, the set A has a 5 and C, the set B of have a 5 and C, but we can't say that B is in A, or we can't say this is true now, because we said that the set B is not an element of A, because this set B is not an element, it's just a set by itself. So for example, if there is a California Zoo here, and this we can see as a C, and New York, say for example New York Zoo, so this one have a zebra and this one have a lion, but this one's also have a zebra, but this one also has a line, so we consider this one, we assume this one California Zoo has a zebra and line, and this one also New York Zoo also has a new zebra and line. They have a common members or objects, whatever you guys can see, or items, but we can't say that this one is an element of, say for example, NY. We can't say this one because California Zoo is not an element of New York Zoo, just because they have a common items or members. So now we're gonna see that the relationship between sets. For two sets to be equal, they must exactly have the same elements. So we can see that the first one is 1 2 3 and 2 1 3. So now if I ask you, is this both the same? Because if you remember, we said that the order is not important. Whatever the items is important, but we don't look at the order. So 1 2 3 is the same as 2 1 3. So they're all the same. We usually use English capitals as A, B, and C and D to name our sets, as we already discussed that one in the previous videos. And we say that example, we said that aunt and zebra, B is zebra is aunt, and zebra aunt and zebra. So now if you tell me all these sets, the first one has an aunt and zebra, the second one zebra and aunt, because we said that the order is not very important, and the elements are important, or the objects, our elements, our members are important, but the order is not important. And we look in here, they're all the same. So A, which contains a ant and zebra, B, which contains zebra and ant, and the C, which contains zebra, ant, and zebra, and we can say that all of them is the same. The set A, B, and C are all the same and equal to each other. So that's how we're going to write this one, A, B, and C. Say for example, this is X, this is Y, and this is Z. And we don't look at the order. The order is not very important. That's how it's written. But we look at the element, because the objects here, the elements here, the ant, and here it has ant, and here it has ant. Here it has a zebra, it has a zebra here, zebra, it has a zebra. So that's what we're going to see, that one, X equal to Y equal to Z. That's how we're going to see this one. So remember, sets are determined by their elements. As I said to you now, sets are determined by elements, not the order. And number 3, not the number of times each elements are represented. So look at here, maybe we have ant and zebra ants, and this in order, this is not in order, and here this number repeats. So zebra and zebra, we have 2 items here, and we have 1 item of zebra in each set, but they're all the same. So the number 3 that you guys need to remember, not the number of times each elements are represented. So we're going to clean this. So now we're going to see that the set of A, which has 3 elements, 1, 2, and 3, and the set of B has 4 elements, has 1, 2, and 3, and 4. But this set of A is not equal to set B, or set B is not equal to set of A. Whatever order you guys can put it, we can put it set of A is not equal to set of B. Our set of B is not equal to set of A. But every elements of A is here is also elements of B. And it's looking here. Because of this, we say A is a subset of B. So now we're going to see this one, and this we're going to describe subsets in the future slides, not in these ones, because this is just the beginning ones, and we're going to show you guys what is a subset. So we said that A is a subset of B. This A here, this set of A is a subset of B. So that's how we're going to denote this one is a subset. A is a subset of B. Our A is a subset of B. So both of them is the same. When you see this one and this one is both reads as a subset. So I missed the H here, sorry for that. Just both read as a subset. So why this A, set of A, is not equal to set of B? Because if you look in here, this has a elements, but look at here, this has a number 4, but this one doesn't have a number 4. Even if you have say for example number 3 here, but if you put a number 3, then it becomes equal. So, and then we can again say A equal to B if you put it 3 here. But because we don't look at the order, we only look at the objects or items here. But since this one have a number 4, that's what is not equal. But there is another there is another way which we're going to say that the set of A is a subset of B. So that's how we denote the subset. And if you look in here, it's the sideway U, and this one's sideway U with underline line here underneath. So they both read as a subset. A is a subset of B, or we can denote this one as A subset of B. So that's how we're going to denote. Alright guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.
You